The properties of ionic compounds. Now these properties all have to do with the fact that you have these charged subatomic particles where they have become ions. So let's look at what these properties are. First, there's strong bonds. So what is the picture? Well, cover that part up for right now. It's a strong witch. You'll see why I use a witch here in a little bit. But you need to remember that ionic compounds have very strong bonds. All right, because they have strong bonds, they have high melting point and high boiling point. It takes a lot of energy to change states here. So, since they have strong bonds, they have a high melting point and a high boiling point. I'm melting. Not really melting, she's dissolving. Because ionic compounds dissolve in water. All right, I thought I said they had high melting points and boiling points and they had strong bonds. They do, but because they are ions, with those positive and negative charges, they can dissolve in water. This is due to the fact that water has a slight positive charge and a slight negative charge. We'll look a little bit more about that later. Don't you love my witch? Also, another property of ionic compounds is they conduct electricity, whether they are melted or dissolved. Why is this? Well, because of the positive and negative charges about them, the protons all line up and the electrons kind of switch places. That's how electricity works. Electricity is electrons moving. And so, therefore, since ionic compounds have ionic charges, they conduct electricity. They are all solids. Number 5 is they are all solids. And they have a very particular structure. It is called the crystalline lattice structure. So the actual atoms will line up like this. And a lot of times under the microscope, you'll see it, and those from a little bit further distance away from just looking at the actual atoms, you see this lattice that kind of looks like a trellis. What do I call an ionic compound? When sodium and chlorine come together to form NaCl, an ionic compound, but what is it called? All right, there's a basic rule, because we're going to get into a more complex way, but I want you to understand the basic rule of how to name ionic compounds. So you name the metal first, then you name the nonmetal, but you change the suffix or the ending to IDE. So sodium and chlorine become sodium chloride. All right, on number 1 and 2 here, these are bonus if you will look these up. And I will ask them on the quiz and or on the test. So let's look on down to naming the following compounds. And then we're going to give the equation. So remember the rules, the basic rules. Name the metal, name the nonmetal, but change the suffix to IDE. So go ahead and pause it, and then you're going to name these. Sodium iodide, magnesium nitride. Remember, change the ending to IDE. So let's take a look at number 4. It says, give the equation of the following compounds. What does it mean by equations? That's the chemical formula. The very first thing that you need to do is to get the oxidation state or the ionic charge that each of these elements have. Potassium, which is number 19 on the periodic table, right here. Potassium is in group 1, so it has a oxidation number of +1. Oxide, if we remove the IDE and put back on the other ending, it's oxygen. Oxygen, atomic number 8. It is in group 16, so it has 6 valence electrons, so it will gain 2 negatives, so its oxidation state is -2. So you write that down, and then you have to determine how many of each you need to be able to balance this. In other words, if we have a -2, we need to make enough potassium to make a +2, so this can be balanced. So how many potassium do we need to be able to get this balance to 0? We would need 2 potassium. So if that makes that a +2, then we only need 1 oxygen. And remember, we don't have to write a 1 down because it is already implied. So let's go on down to the next one. We have got barium and fluorine. Barium is in column 2, group 2, number 56. It's in group 2, so it has 2 valence electrons, so it'll have a +2. It will have a +2 because it's going to get rid of 2 electrons, so it'll have a +2 or a +2 charge. And fluorine is in column 17. It has 7 valence electrons, so it needs an additional negative charge. So its oxidation state is -1. So we want to balance this to 0. So if we have +2, to be able to get rid of the +2, we need to have 2 fluorines. So we have 1 barium and 2 fluorines.